Hello everyone. Welcome to the course Power Electronics and Laboratory. I'm very happy to teach this course to everyone in online as well as in offline. Let me introduce myself first. My name is Yongsug Suh. Now I'm working at the University of CHONBUCK, National University, at the Department of Electrical Engineering. And this course, Power Electronics, is offered to senior level. So at this lecture, I'm going to introduce or explain about the course curriculum briefly. And then also I'll explain what kinds of topics will be covered in this power electronic course. So if you look at the screen, this is about the course syllabus. This course syllabus, the format is written in terms of ABIC, Accreditation Board of Engineering Education. In Korean is 공학인증. This is 공학인증 syllabus. So first, we are learning about the power electronics. In Korean, it is 전력전자 및 실험. And as you can listen to my voice, I'm speaking in English. So this course is offered in English. But I know that the majority of the listeners are native Koreans, so I'll try to do my best to explain English terminology in Korean. So when it comes to difficult words or the very specialized terminology, I will explain in Korean. And when it comes to quite a difficult concept to explain, then I will time to time use Koreans. Okay, so this course is offered on campus too. Okay, of course this course is now videotaped, but this course is now offered on campus. So the students who are taking the course from the videotape, you will see that there are some interactions between myself and then the students on campus. So the lecture is offered on Tuesday, the first and second hour, and then Thursday and third and fourth. Okay, and the lecture room is Engineering Hall 7, the room number 534. And this course has 3 credits and 2 credits for the theory, and 1 credit is for the laboratory. As the name implies, this course also has some laboratory syllabus or course program. So for those who are taking this course from online, I will make some brief project so that you can also do the lab simulation at your own. Of course, you cannot do power electronics experiment at your own place. So I'm thinking of kind of computer simulation using power electronic software. So everybody who is taking this course from online can also do this power electronics laboratory. Okay? So to tell you once again, I'm going to give you a power electronic simulation project for those who are taking this course from online. Okay? And this course is also offered to senior level course, so senior level. So what about the prerequisite? In Korean is 선수 과목, prerequisite. There are several prerequisites, but the official one is circuit analysis, because power electronics is about the circuit system. So I hope, or I ask then most of you who are taking this course should have some knowledge about circuit analysis in advance. And these terms are from ABIC, 공학 인증. This is it's not compulsory, so student can select. And this course is classified as laboratory because it has 1 credit for the lab. And for the CHONBUCK National University rule, this course is also major but not compulsory, a selective one. Okay? And I know that this course is offered in English, so it's not so easy for those who have not good skill in English. So I'm open to your suggestion and your questions. So please don't hesitate to ask me questions. I will have my office hour on Friday from 4 to 7 p.m. So whenever you have a question about coursework or any other point, then you can come to my office and we can have a chat. And my office phone number is 063-270-3381. Okay? My office is located in Engineering Hall 213. And I will use the homepage, course homepage, to communicate with all of your students. So there will be some course material as well as course announcement. This will be posted through the website. This website is efec.re.kr. This is our graduate school laboratory website. And also you can send me mail. My mail is ysuh@chonbuk.ac.kr. Okay. And we have a teaching assistant. Okay, let me introduce our teaching assistant. Mr. Park, could you come forward and briefly introduce yourself?
Hi, my name is Yongsug Suh. I will assist you about this course. Thank you.
Okay, so Mr. Park is now a master student in my laboratory in graduate school. So he has also an office hour on Wednesday from 7 to 9 p.m. and also Friday 7 to 9 p.m. So if you have any question, you can come to TA office. Okay, and his phone number is 01040271007. Okay, and his lab is located in the Engineering Hall 7th. Third floor, 307-1, and his mail address is queenjet00@nate.com. Okay, the reason why I'm stressing this is please ask questions. Okay, whenever you have a question, please come to me or as well as TA. So ask. There is no any stupid question. Okay, so you can ask as many questions as possible. Okay, I will try to do my best to assist you to answer or help you. Okay. So let me now talk about this course, power electronics. What is power electronics? So before I talk about power electronics, let me iterate or state the course aim, the goal, 목표. Right? It's always good to know about our goal so that you can have same direction to get with myself. So this course is directed to study and investigate principles and application of power electronics. Okay? So here are the terms, principles and applications of power electronics. So this course will cover not only the principle but also applications. But due to the limited time, I think we will not cover many different kinds of applications, but I'll do my best to show you as many applications as possible. Okay? Actually, power electronics is known as a very applied engineering. Okay, applied. It's not pure engineering course. So it's good to know about application fields. Okay, power electronics is very much multidisciplinary and applied courses. 그러니까 전력전자가 굉장히 그 응용 학문이고 그다음에 다학제적인 분야이기 때문에 여러분들한테 그 뭡니까 그 다양한 응용 분야에 대해서 제가 가능한 한 많이 설명해 드리겠습니다. Okay, then various types of power converters are explained through the synthesis of basic switching cell arrays. Okay, power converters are the heart of power electronics, but unfortunately, we have lots of kinds of power converters. Okay, so classical courses. Okay, this power electronic course is dated almost 70s or 60s. Okay, this is very classical field. But on those days, students or some professors teach each converters separately. So students are overwhelmed by many different kinds of converter circuit. This is very special, particularly true for DC-DC converters. DC-DC converters, there are many different kinds of converters. And fortunately, or unfortunately for students, there are many new emerging converter types developed by this power electronics academia. So it's a never-ending story to memorize and understand all these power converters. Okay? So what can we do? What can we do? Okay? The point that I like to stress is you don't or you shouldn't study or memorize each converter circuit, but you have to understand the principles. Once you know about the principles, then you can understand or know other unknown topologies. So how can we tackle about this? We studied basic switching cell arrays, and we kind of study how we can synthesize the difficult topology based on this. So once you know about this synthesis in Korean meaning 합성, so once you know how to synthesize the circuit, then you can understand various kinds of circuits. Okay? So the key point here is we start from basic switching cell and then how to synthesize power converters. Okay? And actually this is my favorite area of research. You know, I like to study topology based from simple switching cell arrays. And then the last point is once we know about the topology or synthesis of the circuit, then we study operating characteristics and control techniques of each converter. So because of limited time, I think this course is offered in 15 weeks. We will not take a look all these kinds of converters, but we will select most representative topologies, and we will discuss these operating characteristics and control techniques. Okay? And what are the main scopes? The first, principle of static power conversion, as I told you before. And then switching cell structure, the basic switching cell arrays. So, and number two, we will briefly touch on how we can synthesize the circuit. And then the third point is DC-DC converter and AC-DC converter and DC-AC converters. Okay? These are just one example of grouping the converters. So you can group the converters in different ways, but this is just one example. You can ask me a question, where is AC to AC, right? AC to AC. Actually, AC to AC converters is now emerging very fast, like matrix converters. But since this topology is quite advanced, I will not go in detail about this area. Okay? Now, these are written in Korean, so you can have a look at this. This is about ABIC, the 공학인증 is the terminology. So our department in Jeonbuk National University, this 전기공학과 in 전북대학교, we have our own program goal, and this course should have some kind of relationship with this program goal. We have our department has 4 goals. First one is 공학 기초 확립, second one is 분석 설계 능력, the third one is 공학 실무 능력, and the fourth is 직업 윤리 및 국제화. So for those who are taking this course off campus, you may have a different goals. If your department is part of this 공학인증, okay? So, but in our case, we have these 4 goals, and this course has some relationship with each of these goals with this percentage, 24%, 35%, 35%, and 6%. So as you can see this course is aimed to focus on 분석 설계 능력 and then 공학 실무 능력, okay? And these are because this course is kind of applied or application-oriented course in industry. So 공학 기초 확립에서는 전자기학, 전기회로 기초 이론을 응용하여 전력 변환 원리를 이해한다. 분석 설계 능력에서는 각종 전력 변환기의 동작 특성을 습득하고 전력전자 회로 시뮬레이터를 이용하여 주어진 입출력 특성을 설계 및 검증한다. So that as you can see, this 전력 변환기 power converters is good that you have to understand and know about the power converters, okay? And the third one is about the application. 여러 전기에너지 변환 시스템에서의 전력 변환기 역할을 이해하고 현재 산업체에서 이용되고 있는 핵심 전력 변환기의 종류를 고찰한다. So I'm gonna give you some examples of how the power converters are applied. Actually, without realizing, power electronics is everywhere around your everyday life. So, for example, this lecture, where is the power electronics? First, light, okay, the light. We have a ballast resonant converters used in this fluorescent light power supply. And what about the projector, okay, the source of the light? We have also a LED, LCD driver or backlight, okay, HID backlight system. That is also part of the resonant converter. And power supplies. Power supply for this computer. And computer has power supply, and this power supply is a AC/DC converter. And we have a flyback or forward type converters. And what else do we have in this lecture room? Okay, air conditioner. We have an air conditioner, and air conditioner inside we have a pump or fan motor, and this motor is driven by inverters, 3-phase inverters, and that is the key example of DC-AC inverter, okay, sometimes called converter. So, I mean, you will be surprised to know that the power electronic circuits are everywhere around us. So I think this is why power electronics is becoming more and important in industry. Okay. So the final one, 직업 윤리 및 국제화. This is also very important, right? We are not just studying for our knowledge, but we are studying to enhance our ethics, and we like to become globalized. Off-campus students may not realize, but we have several foreign students now taking this course. Some of them are from China, and some of them are from Mongol. Okay, so this course is now becoming, I hope, more globalized. So I taught in English. And the course material is also, I pick up the English textbook, okay. And teamwork. Teamwork is also the core of this occupational ethics. So I will assign team project for each group, okay? And then I will grade the teamwork based on this your team report, okay? I know it's not so easy to work as a group, but then this is the skill that you have to learn at your earliest career stage, okay? You know, to work together with somebody else is quite difficult. Okay, so as a student, I hope you have to be prepared to learn this technique. Okay, you know, and especially for engineers, engineers are notorious for not having good human network. Okay, so in order to break this, you know, this prejudice, so you have to know, or you have to be well equipped with these human network skills. Okay. So what is the course material? Actually, this course will follow my own course note. So this course note will be posted in the website. But I have a major reference book. This reference book is Power Electronics, 3rd edition, written by Professor Mohan. Professor Mohan is from University of Minnesota, Twin Cities, and this book is quite popular in power electronics area. And in my opinion, okay, there are some goods and some bad, but the advantage of this book is it covers almost every field of power electronics. It is very comprehensive. It covers almost every area, okay? And also it covers from very theoretical part as well as very applied oriented part. So this book is very thick, so it covers a lot of fields. So that's why the depth is not so, you know, it's not so deep, okay? So if you want to study deep, and this textbook is not so much, what you call, well adapted, okay? But for like an introductory course for the beginners in this area, I think this is good textbook, okay? And what about our course? Now, as you can see, this course is now offered in lecture, and also we have some laboratory. But the laboratory, this will be carried as power electronic simulations. Okay, and I have some group discussions. So maybe this will be taken care separately from the videotape, but during this videotape, the lecture, I will time to time ask questions to each group, okay? So the students who are taking this course from off campus can notice that I'm giving some questions to students. And we have a homework. I'm going to explain about homework later, but we have homework. And I will time to time use PowerPoint slide. Okay, my lecture style is I very much like to write down my own handwriting. Okay, because I have a bad experience as a student, as I always easily fell into sleep whenever I look at the PowerPoint slide. Okay, that's the one reason. So I think most of you agree. Okay, the best way to be awake is to write by yourself. But the second point is, writing is kind of, you are using another sense organ. Okay, so you're writing, listening, looking, so you can combine these all organs at the same time, which means then you can improve your learning kind of mechanism. So, and the third point is, these days students are not so much well prepared about writing. So writing skills is also important for good engineers. So, and that's why I like to avoid using PowerPoint slide. But when it comes to very difficult drawings or complicated equation, I will use a PowerPoint slide, maybe 20%. So 80% I will rely on handwriting or whiteboard writing, and then 80% is about the PowerPoint slide. Okay? And the grading system, this is the most interesting area for you, right? Grading system. So we have a midterm exam and final exam. Each has the weight of 25%. For off-campus student, I will also prepare for this midterm and final exam. Of course, you have to be disciplined by yourself. You have to make quiet place, and you have to sit down yourself and solve for this exam. So I believe you will not take a look at the books while you are solving for the questions. But anyway, so we have a midterm exam, final exam, and we have two homeworks and one report from the simulation. Okay, that counts as a 30%. And I will also check how you respond to my questions. So the group discussion and presentation is accounted for 10%, and attendance is 10%. So total, it amounts to 100%. Okay? And the course is evaluated based on absolute rating. So in CHONBUCK National University, every course offered in English has absolute basis evaluation. Okay? So this is not an exception. If we go detail about the lecture schedule, although I'm not following exact sequence of the textbook, but I try to follow the course structure. So I wrote down the related to course chapter. The first, this week I will talk course introduction, and we have a pre-test. Okay, pre-test. Pre-test is necessary according to ABIC protocol. 공학인증 수강 능력이 있는지를 사실 체크를 하는 그런 과정이 있습니다. pre-test. So this is gonna be given in next class, and it will have the question of how many, like 4, around 5. So I will also distribute this pre-test to off-campus students. Okay, so you can check your prerequisite course knowledge by solving this pre-test. And then now chapter 1 is about introductory, about power electronics, and chapter 3 are about some basic electrical circuit concept and some of the power concept. Okay, and chapter 2 is skipped. Chapter 2 is about the power semiconductor devices, but I'm not gonna cover this area in this semester. Chapter 3 is about basic electrical concepts, especially power. The reason why I review on this is the concept of power is so important. So also power factor and THD and Fourier series, those are reviewed on chapter 3. Then we have one homework. Okay. Then now we proceed into chapter 7, which I believe this is a DC-DC converter. Okay, DC-DC converter. Okay, then now we do midterm exam, and then we cover chapter 8. Okay, and I think this is a inverter. Okay, inverter, and then chapter 5 we cover the rectifier. You know, so this is quite different from classical approach. In classical textbook, people usually start with a rectifier, diode rectifier. But personally, I think it's not a good sequence, because rectifier is a very old technology. So it's good that you know the new technology first. So we start with DC-DC converters. Okay. So homework 3 is about the simulation report. You will have a chance to do the simulation using a software called Plex. So I will give one, maybe two examples of simulating the power converters. So you simulate this and you kind of solve some questions and then make a report. Then this will be our homework 3. So you have two theoretical homeworks and one simulation homeworks. And then on the last week we have a final exam. Okay? And this is another area of 공학인증 ABIC. Our program has 12 program outcomes from P1 to P12. I'm not going to explain this in detail, but for those who are interested at ABIC, please take a look at this page. Okay? Okay, so I really welcome you to this wonderful world of power electronics. So, okay, but anyway, my philosophy is it's important to have a fun. Okay, so in this semester, I hope everybody enjoys this course and has fun together with myself. And I also had many opportunities or experience taking course from off-campus video course while I was studying for graduate study. And actually it's very difficult to finish taking a course by watching this videotape. You have to be very patient and you have to be very disciplined or self-control. Otherwise, maybe after 2 or 3 and 4th, then you will be very exhausted and you will be tired of watching the screen. So actually, you have to be very self-control. Otherwise, it's very difficult to finish. And so I'll do my best to make this course very live and not boring. Okay, so I will try to do my best to transfer this atmosphere of this lecture room through the camera and to the screen. Okay. Okay, hello everyone. Welcome to Power Electronics and Laboratory. Today's lecture, we will now discuss what is power electronics. What is power electronics? So this is about the chapter 1 in your course reference book. So today I will try to define or explain power electronics as a simple text. Okay? What is power electronics? So before we talk about power electronics, I'd like to briefly touch on the concept of electricity. What is electricity? Okay? I think this is not so easy questions. You are all now senior level, so after 1 year you will graduate and you will have a bachelor degree in electrical engineering. And what is electricity? 고유란 학생, what is electricity? What do you think? Huh? Yeah, it's not so easy question to answer in simple text. Actually, I don't know either. Huh? It's not so easy. But let me change the question in different way. Why is electricity useful? 강태원 학생, why is electricity useful?
Many people use.
Many people use. That's why it's useful. Okay. You're talking from the result. Okay. I know this is not so easy question, but the reason why I'm asking you is please think about this. What is electricity and why it is useful? Okay. in my opinion, in my perspective, there are two different aspects for electricity. First one is information, and the second thing is power or energy. Actually, electricity is merely a flow of electrons, right? Electron is flowing, and we call it that's current, and that's electricity. But why is it useful? Because electricity carries information. So-called signal, and delivers power. So we have two different aspects. First one is information, and the second one is power. Okay? It's not so much surprising that we can classify all these lectures, all these courses in electrical engineering into two sectors. One is related with information, and the other one is related with power. What about information courses like communication, optical communication, and signal and system and controls? What else? Like electronic circuit. Those courses deal with this information aspect of electricity, right? Electricity, we can deliver the information, both in analog form and both in digital form, right? In digital 1010, we quantize analog signal into digital, and we send out the information. And electricity can also deliver the power. Okay? At the moment, electricity is by far the most efficient media of delivering the power. Okay? The power is created where? At the power plant, 발전소, right? And is dispatched over the long distance as a form of electricity, and is delivered to each factory or each house, and we use this electricity. Okay? I think most people take this for granted, but it wasn't like this maybe 70 years ago. Okay, maybe I have one interesting story. When Niagara Falls built hydro plant, 수력발전소 hydro plant, it generates huge amount of power. Okay, they installed generators. Now, they were wondering what's the best media to transfer the power. Of course, these days, electricity. But that times, people also considered fluid. Okay, UAP, fluid. They delivered the power using this fast flow of the water, right? It's like in this day we also get hot water from the local combined heat generation, right? 열병합 발전소 여러분들 뜨거운 물 봤죠? 그것도 일종의 파워를 전달받는 거죠. And that was one possible candidate in Niagara Falls. But then they decided to adopt electricity as a means of delivering the power. Okay? So the reason why I'm telling this story is that electricity is one example of delivering the power, and we have other possibilities too, like using fluid. So as a student in electrical engineering, you should know that electricity is the best and most efficient media to transfer the power. Okay? Transmission line, power system, power grid. Everything about this delivers power. Okay? So power electronics, as you can tell, we are studying about this delivering the power. Okay? Delivering the power. But then now, why we are using electricity and why we are using power? or why we are using power electronics. Unfortunately, the end users, we are using different formats of energy. For example, the light, we are using the light energy, and mechanical, we are using some mechanical energy, and what else? Like thermal, we are using thermal energy. So which means we have to convert back from electricity into other forms of energy, okay, to make it useful. So that means we need some kind of power conversion process to convert it from electricity to different types of energy, lighting or thermal or mechanical or sound, whatever. Okay? So that power conversion is done by a device called power converter, and we are studying power converter. So let me explain this power conversion using the analogy of the signal processing. So this is a signal processor, okay? People often use this kind of analogy to explain power electronics, okay? Power electronic engineers use this analogy as compared to signal processing, okay? Power conversion and signal conversion. So we have an input signal. This is a given. Okay? And we have an output signal. Usually input signal is given, right? And then we like to get output signal. Also, the format is given by the specifications. So we have to somehow change the format from input signal to output signals. Okay? And we need a power. We need a power to maintain this processing unit. You can picture this as a bias circuit in electronic amplifier. You know, in BJT amplifier, you are using DC bias circuit, and this is kind of powering the circuit. Okay, and this area is called microelectronics. Okay, microelectronics. To be more specific about this explanation, let me give you an example. Like, what about amplitude modulation in radio signal? Let's say we have some voice. We have some voice signal. Okay. So we have a voice signal in audio frequency. Audio frequency is around 1 kilohertz, right? Audio frequency signal. And everybody knows that we cannot dispatch this audio signal for the long distance. So we have to modulate. Modulate means we have to integrate this audio signal information into carrier waveform. Okay? That process is called modulation. And we use kind of amplitude modulation. And we use the carrier waveform. Okay. Maybe this should be symmetrical, but I just show only this upper half of this. So this process called amplitude modulation, right? So this should be like symmetric. it's gonna be like this. Sorry about this lousy drawing. Okay. So this is amplitude modulation. So we kind of convert the signal from the audio frequency to this higher frequency modulation. This, how much is the AM frequency range? Do you listen to AM these days? Megahertz? Megahertz? Kilohertz? No, I think it's megahertz. So you change the input signal from kilohertz to megahertz by this technique. This output signal is obtained using this signal processor. Okay? And for those who are interested in communication, you know how to deal with this amplitude modulation. You know, you use some, I don't know, heterodyne. It's a long time ago. So this is kind of signal processors. And what about power electronics? We have the similar forms called power processor. And we have input power instead of input signal. And here we have output power. Okay, so like output signal, output power is determined from customer side, and we have input power given from the outside. And here we have kind of control signal. Controlling this power processor. And this control signal is usually created by a digital signal processor in DSP board, okay, in power electronics. So power process is processing the power from input power to make useful output power. So we now describe this as a power electronics. So microelectronics, power electronics, okay? So what could be a good example? Okay, these days the mobile phone is becoming very, very popular, and you charge the mobile phone every day, okay, to make it last longer. And this charger has a battery voltage of 3.7 volt. DC. And here, input power is how much? In residential area, we have a 220 AC volt, 60 hertz, okay? And so we have to change the format of this electric power from 220 volt AC into 3.7 volt DC. And that power is processed by this power processor, okay? In power electronic terms, we say this AC-DC converter. Power is processed. Power is processed. Input power and output power. Okay, now let me talk about performance factors. How can you describe the signal process as good or bad? What could be a good index? When do you say this system works fine? We usually say output signal is created as we want. It means it doesn't contain what we don't want. What we don't want? Noise, right? Noise. Noise is problem, noise. Noise is a bad thing in signal processor. We have to live with this noise, but we have to clear this noise. Okay? When you listen to radio, does it always have a good quality? No, it has some noise. So the good signal processor, or good radio, can always eliminate noise. So what is performance factor is signal to noise ratio. Signal to noise ratio. 신호 대 잡음비, signal to noise ratio. That is a good performance factor. 하나의 그 성능 지표죠. Signal to noise ratio. And what could be a good analogy or good counterpart in power electronics? What is playing like a noise? 현철 학생. Efficiency. So you go one step further. Loss. Okay? Loss is a worst thing. We don't want the loss to be made. Why? Because we are processing the power. Okay? I think there is no concept like a noise in power. Okay? The power loss is more important. Loss. Why? Because we are dealing with power. We don't want to be lossy. Okay? So, as Hyunchul answered, what could be the important performance factor is efficiency. Output power divided by input power. How much power is well transferred to the outside, to the output? That performance factor is efficiency. So efficiency is everything. Efficiency is everything. So when you evaluate power converters at the end, efficiency is a so important factor. If efficiency is very lousy, then it has no meaning to use power converters, right? Because power converter is everything about power processing. If efficiency is low, then it loses its identity. Okay? So, this is my favorite explanation about my power electronics. I use the comparison with signal processor, but the key concept is power electronics is dealing with this delivering power aspect of electricity, and power process has input and output. So whenever you study power converters, you should think, what is input, what is output? Okay? What is input and what is output? And what should we do? And how much is loss? Okay, these are basic things. Okay. Now let's take a look. What are the types of output power? What should we change? What should we change? Before I said 220 AC volt, and here is DC. So AC DC. Changing AC DC is the everything? No, actually we have other types of power. So let's gonna discuss this. So types of input-output power. What do you mean by types? What do I mean by types? Types means what should we change? What should we transform? What should we convert? Okay. First, I explained this before. What is this? AC and DC. The form of the electrical energy can take either AC or DC. What is AC? Yachung?
Voltage will be can be negative and positive.
Positive and negative, right? So what does it stand for, AC? Literally, A stands for what? Alternating current, and DC stands for direct current. So it's weird that these two words meaning only the current. but we used to mean also the voltage too, right? It means both current and voltage. So as Ya-chung answered, AC should take the positive and negative. But sometimes this will be tricky, because what about this signal? This signal has only the positive value. So according to Ya-chung's definition, this is DC. But we treat this as a mixture of DC plus AC. Okay? So the more definitive, more exact definition of AC is like alternating. Okay? It's changing the value. Oscillatory. And direct is a constant. Okay? Because this can be broken down into this and this. Okay? So this is DC and this is AC. So this AC plus DC. Okay? I think this is a common mistake that people make. This is AC plus DC. We usually say this has an offset here and the ripples on top of this. So AC, DC now can both be voltage and current. Okay? So please don't think that this is only applied in voltage. Current can be either AC, DC, and voltage can either be AC or DC. Okay? What else? So what I'm now discussing is this input power can be AC and output power can be DC, and output power can be AC or DC, whatever. Who determines this? The type of load. The load determines this type of the voltage. Right? Like if the input is solar cell and fuel cell, and these will take DC voltage, right? And if we want if we connect to the motor, we want to have AC. So we should have DC to AC power conversion. So usually output power shape and input power shape are determined from the output side, and you have to conform with these given conditions. Okay, next, what could be an example? What is the types of power? 정경섭 학생. Frequency. Thank you. Frequency can be different. So frequency only applies to AC, right? There is no frequency in DC. Huh? Frequency. So when we change from 50, okay, in Korea, what's the standard frequency? 60. But in Europe, we have a 50 hertz. So in Europe, in European continent, they have some frequency changer from 50 to 60 and 60 to 50, right? In this case, frequency is a key, types of this power. Okay? So in AC, frequency is a key factor. And what else in AC? 고일한 학생? What could be the other important types of AC signal? Phase. This phase is also important in power flow. Power electronics is used in power system as a big devices. We have lots of power electronics tools called FACTS. FACTS device. FACTS. I think this is one of the very hot areas in these days. flexible AC transmission system. So the power converter sizing like this whole whiteboard is installed in the power transmission system, like a static var compensator, universal power flow controller, and all these systems will control the power flow, okay? And those power flow controlling unit, this phase is so important. Why? You know that the power flowing from different point depends on the phase angle, okay? So power electronics control the phase, maybe phase 0 to some kind of different phase, okay? So frequency and phase. And what else? Any other suggestion from audience? 김창호 학생. Huh? Voltage and current. Thank you. Voltage and current. This may sound weird to some of the students. What do you mean by voltage and current? Here we have a source shaped as a voltage, but then we have to change it to current. Or we have to change from the current to the voltage. Now you may question yourself, Professor, voltage and current, they all related to each other with Ohm's law? Yes, correct. But what I'm now saying, voltage and current is about the source type, okay? Which means we can have a voltage source or we can have a current source, but we can change to current source or voltage source, different types. I'm going to explain this maybe next week about when we discuss the source type. Actually, in engineering world, source doesn't exist. What is the source? Source is another way of saying inductor and capacitor. Voltage source is a capacitor and current source is an inductor. Okay? So, for example, like a fuel cell and the solar cell will naturally be voltage source, DC voltage source. Okay? And the motor or generator are the current source or load because they have a huge inductance, magnetizing inductance. So we have a different kind of the source types. So we need to have some kind of interface power conversion. Otherwise, we will violate the electrical circuit rule. What is this? The short the voltage source or the open the current source. We should avoid this kind of action. What happens when you short the voltage source? There will be very high current, short current flowing. It will burn everything. Okay? So we like to avoid this kind of scenario by having some kind of power processor. And what else? 강태원 학생. Any other idea? What could be a type of power or here? 정경섭 학생. Huh? You ran out of your idea. What about this? Continuous and the pulse. The pulse is the opposite word of continuous, opposite concept. Continuous. Of course, we can have some continuous power flowing. Okay? But sometimes we won't use it as a pulse. Let me give you an example. What about this? If this is continuous power, and this is pulse type. What is pulse? What does it mean, pulse? It's a discontinuous. Discontinuous is a momentary power. Like the good example is, do you know these days space shuttle? Okay, the rockets, they launch it using this combustion engine. But some scientists and engineers are working on magnetic levitated this ejector. Okay, it's like how can I explain? It's like a magnetically levitate train, but with going very fast. Right? Have you ever seen this? No? Anyway, so we brought some continuous power and stored, and then we released the power at very short moment. Boom. So it will take off the space shuttle to the space by using this technique. Okay? And that can be a good example. What about the reverse one? Pulse. Continuous. Pulse or continuous. Good example is solar cell. Okay? Solar cell is the sun. The sun doesn't always shine. Okay? We have a night. Somewhere, if it's cloudy, the power doesn't come from the solar cell. So we have to store or accumulate the power and then release it to the residential area continuously. So we need kind of this power process to deal with pulse type source to make it continuous output. Okay? So these are all handled by intelligent power electronics converters. And the last point is it's similar to continuous pulse, but we have the form of energy and power. Sometimes we like to provide power in terms of energy, and sometimes we get the power in the form of energy. So this is quite similar, and these are all handled by power electronics. Okay. So power electronics, if you learn more about power electronics, you will understand that we have a huge examples around our everyday life. So let me give you one example where the power electronics is actively used. The screen shows this adjustable speed drive. One example is called about also motor drives. Okay. So what is this? Okay, first, okay, starting from this famous block diagram, output power is so-called three-phase motor. Okay, I like to drive motor. And input is three-phase voltage. Maybe 220 volt, 60 hertz. Okay, amplitude is fixed and frequency is fixed, phase is fixed. It's a continuous type power. Okay, we get the power from KEPCO, 한국전력, continuously, right? It's not pulse, three-phase. Then we like to have a three-phase motor. And motor is hooked up to fan. Okay, this fan is doing some useful things. So let's say the ventilation system, ventilation. You know, every building, every room has 환기 system, ventilation, okay, to recirculate this air, right? How can you circulate the air? By blowing the fan. Where is the fan? At the basement of the building, right? They blow the big fan, okay? So they can send the cool wind or hot wind, right? So if the temperature is varying, you have to control the temperature. Okay, now we are in the winter, so let's talk about this hot air. Okay, today I think it's not so cold, so the engineers they like to maintain the temperature low enough, so they lower the flow of hot gas, hot air. But since the motor is hooked up to this fixed voltage and fixed frequency, the motor speed is fixed, okay? Constant speed. The fan is blowing constant, okay? Then how can you control the amount of hot air? By so-called mechanical valve or damper, okay? You have to rotate the valve, or like every room has this kind of radiator valve, right? Here, you rotate this and control the amount of airflow or liquid flow, okay, fluid flow. And this will create huge amount of power loss because the power is feeding continuously, okay? So when you control the valve and damper, then the power should be lost as a means of heat. So it's not so efficient. So efficiency is ranging around 40% or 50%. Okay. So the load process, in our example, the hot air control can be varied through mechanical devices. So it's inefficient. Now, let's use power electronics. Okay, now let's use power electronics. In our case, now, we insert this power electronics in between motor and AC power supply. What is the input here? Same. AC voltage, 220 volt, 60 hertz, fixed frequency, continuous power. Zero phase angle or same phase angle. What is the output? What is the form? Now, variable frequency, variable voltage, a variable phase. Okay? Why? If we have a variable voltage, variable frequency, and variable phase, then we can control the speed of this fan. Everybody knows that if this is a synchronous machine, AC machine, the synchronous frequency depends on the input voltage frequency, right? So if we change the frequency of this inverter, then we can also change the synchronous frequency of this motor, so leading to the speed change. So it means that we don't need to have a damper and valve. So today it's like weather. When it's not so cold, we have to decrease the amount of airflow. Then we control this inverter to lower the frequency. And the fan speed will slowly goes down. Okay? So it means the power flow is also controlled. Do you know how much the efficiency is of the inverter? So around 97%. It's a lot higher than the mechanical system. Think about this, 97% compared to this, or 40 or 50. It's a huge saving of amount of electric power. So that's why now these days people will install this inverter system to replace this classical motor drive system. Okay? So variable speed operation of the motor and load process can be varied through electrical device. So this is very efficient. And this system is called power converter. And here AC one is first converted to DC, and we change DC to variable frequency, variable amplitude, AC. Okay? So in this semester, you're going to learn how these are manipulated, how these are controlled. Okay? So today's lecture, I tried to explain the basic concept of power electronics. So now you should know about power electronics. What is power electronics? Processing the power in static power converter, using static power converter. Power electronics is about energy processing, power processing. That's one aspect of electricity, okay? Delivering the power. You are changing the format of the power. What are the format? The various kinds of things, right? The power converter can change these, interchange these kind of forms, okay? Please don't limit yourself to AC, DC, DC, AC, AC to AC. We have a lot of different kinds of power converters. Okay? And why do we have to change it? Because the load side demands a new format depending on the load process. So actually, power electronics, we have to know about the input and the output, okay? Power electronics is not enough to know only about inside power converter. Why? Without knowing input and output, how can you design the system? So these power electronics engineers also have good knowledge about the source side. Source is usually power system. So we should know well about power system. And also we have to know well about motor. Why? Motor will consume almost 55% of the whole electricity is generated. 55% of whole electricity is consumed in the form of motor. So motor is quite dominant example. So as a power electronics engineers, we should also know about the motor. Okay, so from next class, now we will review on electrical circuit systems and the Fourier series and some of the power concept, power definitions. Okay, thanks a lot.